Welcome back. Today we're going to be looking at adding decoration in Python, and specifically we're going to look at decorators and how you create them, what they're for. And then next week we'll have a look at some built-in decorators that you can use with object-oriented programming. So what does a decorator do? Well, that we'll find out, and it's kind of best to illustrate it with functions. But to recognize a decorator, you just look for this sign, which has many different names, including an andesat, but there's no formally accepted name for it. So here we've got a function, and it just returns this is running. And the difference between this line and this line is just these two brackets. But when we run it, we see that in the first line, it hasn't done anything, it's just told us what the function is. And in the second line, it's actually called the function and got this is running. And with this, we can make functions variables. So add 1 is equal to increment. We're not getting the result of the function, we're just saying that it is the function, and then add 1 is now a function. So we can see if we add 1 to 5, we get 6. Another thing you can do, which is a bit weird, is you can define functions inside of other functions. So we're going to define increment, and then we're going to define add 1, and then we're going to use the add 1 function that we've just defined and then return the result. And so this seems a bit convoluted, but you'll kind of see why as we go on. And so that's 5. So now we've got a different function, but we're using our function as an argument. So we've got increment, which is the same as before, and then we've got a function to call, and this will just call a function. So it gets the function, and then it calls it, and it uses this argument number to add, which is say equal to 3. So it's going to call increment, and so increment will be the function, and then it will run increment with the number 3, and unsurprisingly we get 4. You can also return functions from functions. So here we've got our function, which is a hello function, and it will say hi, and all this function does is return hi. And then we're going to return this function that we've defined inside our function, and then in this case we're going to save it as the hello variable and then run it. And this is actually the same as calling the result of the hello function. As you can see, we get hi. Here we've got something different where we print this message and it generates a function that then prints the message, and this inner function can actually access the message variable, and then we call this inner function when we're doing it. And so when we print some random message, we have message as some random message. We then define this function which then prints the message, and then we run it so that it prints the message. So now we're going to have a look at a decorator function. And so what this function does is it takes in a function, and then it defines a wrapper, and in the wrapper it calls this outer function and saves the result. And then it takes the result and makes it uppercase, and then returns the uppercase version as part of its function. And then when you call the wrapper, it will have called the function and just turn it into uppercase. So we're saying this decorate is the uppercase decorator, which is a function of say hi, and then we just call it and we get hello there in capitals. But this is where the @ symbol appears, because instead of calling a function of uppercase decorator on the say hi function, instead we can just put the @ symbol and then the thing that generates the wrapper. So this time when we say hi, it will take the function say hi, it will call it, make it uppercase, and then return that in this wrapper, and then return the wrapper. So when we say hi, we actually get a function that converts it to capitals. We can also have multiple decorators. So this is something that just splits the string up, and again we're defining our say hi function, but this time we're passing the result into the uppercase decorator, and then we're passing the result of that into the split string decorator. So we end up with hello there. And it's important to note that this one gets applied first and then this one, because if it were the other way around, we'd then split it and then it would try making a list uppercase, which doesn't really make sense. You can have arguments on your function that you're calling with the decorator. So here we've got a favorite language function, and it just prints my favorite language is. And then in this wrapper accepting arguments, which takes in some argument, which is part of this function, it will then print the argument is, and then put in the argument, and then it will call the function, and then it returns this function here. So you see we run that, and we get the argument we've put in, which has come up here, has then been put into this string, and then we've called our initial function, which has gone into the wrapper with the argument. You can also have args and quarks. So, I mean, in this example, we take a function that has no arguments, and then we put print no arguments. And because we've used this wrapper, it's taken in our function, and it will print out all the args and quarks, but of course, there are none. However, we can do it with other stuff. So even though there's a built-in sum function in Python, I've just defined one that takes three variables a, b and c and prints out their sum, and so we can imagine that the sum is 6, but this time it's taken in the positional argument, so the args. There weren't any quarks, so it's just ignore them, and then it's printed out the number 6. Here we've got the same decorator used again, but this time we've put in some quarks, and so this will just display this as a dictionary. And so you see that we haven't got any positional arguments, we've just got these keyword arguments, and it's then passed those in and displayed it as a dictionary. And you can pass arguments into a decorator. So you can see that our decorator has arguments, argument 1, argument 2, argument 3, and then we have our decorator, and then we have a wrapper. So if we just walk through it, so the wrapper, this is a wrapper function. It will print, the wrapper can access all the variables from this decorator and this decorator generator, as well as the function itself, and then we're just putting in all the arguments, and so it returns a function. So you can see this decorator maker takes in all these arguments, it then creates a decorator. It then when we define our function, this decorated function can see the arguments here, here and here, so these are the ones at the end, and the decorated function doesn't know about these external arguments, it only knows about these internal ones, so you can customize your decorator, and then we just call it. And so you can see it's pretty confusing. It's not really necessary to use it this often, and it's more something that's nice to know than useful to work with, but decorators can be very powerful. There are lots of very widely used decorators in Python as well, which we'll have a look at in the next video, because lots of the stuff you can do with classes require some cool decorators. So hopefully you've enjoyed this video, you've learnt a lot, you kind of understand what decorators are, and I'll see you again, same time, next week. Till then.